Now, let's see how this works. Complex numbers have to be added and subtracted. They have to be multiplied and divided. So let's look at some of the issues. Let's start with addition and subtraction with complex numbers. Here we've got, let's call this example where we got z1 as 12 plus j24, and z2 is going to be 16 minus j6. Okay, so if I add them, I'm going to add real separately and imaginary separately. So I take the real part of z1, the real part of z2, and add them, and get 28. I take the imaginary part of z1 algebraically added to the imaginary part of z2, and get 24 minus 6, or 18. So we've got 28 plus j18 for the sum. If I take the difference, it's similar. Since I am subtracting z2 from z1, I will take uh, 12 minus 16 for the real part. And for the imaginary part, I'll be taking 24 minus j6, which is actually plus j6, or 24 plus 6 for the imaginary part, or j30, minus 4 plus j30. Okay, that's pretty easy. So adding and subtracting complex numbers is easy if they're in rectangular form. Of course, if your calculator does this all automatically, then you don't have to worry about that. Let's look at polar form, however. That's a little messier for adding and subtracting, isn't it? Let's define Z3 as magnitude of 10, angle of 30 degrees. Z4 we'll say is a magnitude of 15, angle at minus 20 degrees. If I add them, well, I have to actually break them down into real and imaginary parts so that I can add them. You see, Z3 is up at 30 degrees, and Z4 is down at 20 degrees. It's actually bigger, isn't it? And so when I add these up, I'm going to add like adding vectors, okay? So the resultant would be out here. And let's see how that works. Okay, so I've got to add the real parts and add the imaginary parts. So the real part of Z3 is magnitude 10 times the cosine of 30 degrees. Real part of Z4 is 15 times the cosine of minus 20 degrees. For the imaginaries, for Z3, the imaginary part is 10 times the sine of 30 degrees. And for Z4, the imaginary part is 15 times the sine of minus 20 degrees. Now, if we do the arithmetic here and add the reals, 8.66 and 14.1, I'm going to get 22.76. And for the imaginaries, I get 5 and minus 5.13 for imaginary part of minus 0.13. Okay, so it can be done, but it would have been nicer to do it in rectangular form. Let's look at multiplication and division. We have to do that a lot. For that, it's best to be in polar form. Let's look. Here's Z3 again, 10 at 30 degrees. Z4, 15 at minus 20 degrees. If I want their product, Z3 times Z4, I simply take the product of their magnitudes. 10 times 15 is 150. And for the angle, I take the sum, algebraic sum of their angles. 30 plus a minus 20 will be 10 degrees. So the product was very simple, 150 at an angle of 10 degrees. And notice I'm using degrees. This is perfectly okay when you do this. Now the quotient. Let's divide Z4 by Z3. To do that, I'll take the magnitude of Z4 divided by the magnitude of Z3 right here and get 1.5. For the angles, I'm going to take the difference. I'm going to take, since I'm dividing Z4 by Z3, I take minus 20 degrees minus minus of 30 degrees, so we get a total of minus 50 degrees for that. It's the algebraic difference of the angles for division. Now with rectangular form, multiplying and dividing is a little messier. Let's take a look. Z1 times Z2. All right, we would have then, let's see, Z1 is a real part of 12, and Z2 is a real part of 16. So they would be multiplied. And look at the imaginaries. J24 times minus J6 would be J squared, which is minus 1, times a minus 144, wouldn't it? And that's 24 times 6. So we get a real number by the product of two imaginary numbers. And then for the imaginary parts, I'm going to take J24 times 16, and then I'm going to take 12 times minus J6 for here and here. And when we work that out, the total real part of this is 336. The total imaginary part is 312. Okay, that wasn't too bad. Let's look at division. I'm going to divide Z1 by Z2. Okay, this is messy because it looks like I've got imaginary parts in the denominator. We don't like that. So I'm going to clean that up by multiplying by the complex conjugate of the denominator. That cleans out the denominator nicely, and it doesn't change anything because I'm really multiplying by 1 when I do this. Okay, so now it's back to multiply. 12 times 16, and then add to that J24 times J6 is going to be a negative 144. So we get a net real 48 for the numerator. And then for the imaginaries, we've got J24 times 16 and J6 times 12. And that adds up to 456 for the imaginary part. In the denominator, let's look at this. 16 times 16 plus J6 multiplied by, or minus J6 multiplied by J6. The J's cancel. The J's become 1. And so we've got 256 plus 36, or 292. Divide the 292 into 48 and you get 0.1644. Divide 292 into 456 and you get 1.564. So that's how we do complex number multiplication and division. I think you can see that if you're doing it without a fancy calculator, it's best to do the multiplying and dividing in polar and the subtraction and adding in rectangular.